Welcome to Made Up of Wires. We are decompiling Castlevania Symphony of the Night. We need to figure out what to work on today. I think we're going to keep going on weapons. However, we're getting... there's only a few more weapons to decompile. So on this stream we've been decompiling various functions in Castlevania Symphony of the Night, primarily weapon-related functions in the last few weeks. We're down to 15 remaining in Weapon 0. Over the weekend I took a look at Weapon 1 to see how much work would be there, and it's about the same size. So we're maybe halfway through weapons. If you'd like to know more about the Castlevania Symphony of the Night decompilation project, you can go to SOTN.z.dev. There you will find progress on several of the objects that have been worked on so far. We're working across a few different versions of the game, primarily the PlayStation version, but the PSP version has proven to be fairly useful in finding matches. It was compiled at a lower optimization level, so you're able to go through and match lines more closely to the assembly than something like the PlayStation version, where often instructions get reordered and the generated assembly doesn't necessarily match the order of the code that you were writing. So what's decompilation? That's a good thing to start off a new week with. When games are shipped, they're shipped with binary objects that have machine code, audio, graphics, other data related to executing the game. And what we're trying to do is rewrite the code that was that would have been or could have been used for Castlevania Symphony of the Night. The code that we're writing isn't exactly what was in Symphony of the Night, but when it compiles, it produces a binary that's exactly the same as what was released in the retail games. And so tools like Splat64 are used to split apart binary objects, and then we take the code portions and try to rewrite those so that we can reassemble that with the assets that came from the disk and rebuild the game like it was during the retail release. So there's several objects that we've been working on. The Dracula binary, that's the main game engine. The way PlayStation games are set up, often they have a shim starting program that effectively calls into some address in the main game engine. And these include libraries that were part of the PS1 SDK, as well as potentially patches for functions that were in the BIOS but maybe had bugs or whatever. They can patch that in later versions of the SDK and run local code instead. So that calls into the main game engine. In our case, that's dra.bin. The Richter program is, as you'd expect, the program for the Richter character. The Alucard program hasn't been started yet. Weapon 0 contains about half of the weapons in the game, and we've been working through that and progressing. There's like I said, there's 15 functions left here, some easier than others, and we'll find one to do today. And then we have a bunch of stages that have been worked on, and many of those are complete, some in various stages of completion, but most of the way done on many of those. Any of the code that we've written can be found in the GitHub project that's linked from that SOTN.z.dev page. And that's where we go to submit pull requests to get code in, and all of the metrics that you saw before are based on the code that's in this repository. And then there's also a Discord server that you can join if you're interested in learning more about the project. So how do we find something to work on? I have a workspace that's set up. And if people are interested, feel free to chat. I can go into what it takes to set up a new workspace. We have people working on Windows subsystem for Linux. I'm working on an Ubuntu, just desktop that I have with me here. When I first started working on the project, I was working in an Ubuntu VM. So there's lots of, some people are using Arch Linux, Arch or Arc? Chat, tell me how it goes. I realized over the weekend too that I was mispronouncing Ghidra, and I had no idea that it was named after King Ghidorah from Godzilla fame. So that's good to know. We don't really use Ghidra on this project, but I have used it to look at some of the ARM binaries, and may have something to talk about that in a week or so. So we want to find something to work on. So this is, I've pulled down this GitHub project. This is my directory where I'm working on it. Assets for the weapon object have been extracted into an assembly directory where we have the different modules that we've broken up. And these partitions are based on the modules that came on the game disk, or maybe other information that we've, not we as in me, but we as in the team, have gleaned from researching the game. So we're going to be looking at weapon, and we're looking for functions that haven't been matched yet. We're going to go to the wiki as well to see which ones are furthest from being completed. I think all of these have been started at some point. So I want to find something that's not close, because I know other people are working in this space as well, and don't want to duplicate any of the work that's pretty close to being done. So I'm going to start like I usually do, by using find to find assembly files that haven't been decompiled, and then I usually sort these by size. And we're not going to be able to choose the smallest one because I think that one is almost done. But we can get an idea, work up from the bottom. There's also a nice graph that Biz Murphy has created, which gives us the same information, and I'll pull that up as well. I like to work at the command line. Oops, wrong window. So this is the same set of 15 functions, and we're going to choose one of these. The more towards red, the smaller the function. The more towards green, the larger the function. I spent some time over the weekend looking at Weapon 01. I have a match that's about 70% of the way done there. There's some odd things there that are a little different from the other weapons that I've worked on. So I'm not going to be going into that one today, because I don't think we'd find success by the end. We may want to look at maybe some of these around 50 or 55. And there is another form that we can look at this as well. It's in this wiki, and I always miss the link. So there's a list of the functions that have yet to be decompiled, and we're going to be looking at the weapon functions. And this will actually show us if there are scratches on decomp.me of any progress that's been made towards this. So this weapon 17, entity weapon attack, it's about 82% complete. For weapon 01, which is most of the punching weapons, that's 67. I have another scratch that I don't think has been picked up by the tool yet that's at just over 70%. Let's see what else we have. So some of these are around 90%. I don't want to do the ones that are nearly complete. Oh, and we're missing a bunch of matches here. Or there's no scratches. That could be. So let's look at some of the non-entity weapon attack ones. I think we'll start with this function pointer 04. Is it gonna let me copy that? Close. And we'll go back and we'll look for some of these. Sometimes matching text and images does not work as well as you would hope. So we have a bunch of these. We could choose one in the middle. We have one for weapon 01. That might be useful for figuring out what some of the other stuff in weapon 01 does. So let's try, we'll start there and look at that. I don't know if this is where we'll end up today, but we can start it. So I usually look for jump tables to see if there's any other data that I need to pull in the weapon splat extraction. I've noticed that these functions typically have their, at least for entity weapon attack, they'll have their jump tables in line. And let's open weapon 01 as well. And so this is the second function. So there's a set of several functions that every weapon implements. And entity weapon attack is what happens when the weapon is used to attack. And then many of the other functions we don't have names for. Last week I think we got the entity shield spell weapon named. Maybe that was a couple weeks ago. So we're going to be working on this unnamed weapon. And let me copy that and we'll create a new scratch. And we may look at the PSP assembly for this as well, depending on how this decompile goes. I'm copying the assembly, and I'm going to start a new scratch in decomp.me. This is a collaborative decompilation tool. It acts as a disassembler, a compiler, and then a diff tool between this and the code that we generate. I have to copy I'm using a different profile, so I need to go find my context. The context is a set of function signatures, structures, and other declarations that work like a header file. And so when the decompiler comes through, it's going to use this to help identify how a function call, how it should set up stacks or arguments on the stack, what those arguments are, some variable naming to a certain extent, whether struct access or array access should be used. So the decompiler came through and gave us a first pass, and it's typical that, especially in the weapon functions, we don't have all of the symbols defined yet. We haven't declared what their types are, mostly because this data is only used in the function that we're currently decompiling. And so nobody has previously gone through and decided to give a type to this variable, or even declared that it was a variable to begin with. So I'm going to disable built-ins, which will get rid of some errors. And then we're going to go through and get this scratch compiling. And one second while I find my... I've lost my chat window. There we go. Alright, so the only error that we have to get through to begin with is determining what the type of this variable is. The name comes from the offset of this overlay along with the address in memory. So we're using params, which is an opaque 16-bit value within an entity, to pull a value from this, and that value, this isn't being multiplied by any constant, which suggests that this is a 8-bit value. The type given to A0 is an 8-bit value as well, and so that makes me pretty confident that that is what it is. So this is going to be an array of either signed or unsigned. We'll figure that out in a bit. We could go through and go back to the extracted data as well and search for this symbol in the assembly. And we can look at that and confirm whether or not we think that it really is a set of bytes. When this was extracted, Splat64 came to the conclusion that it was a bunch of bytes. So that's a pretty likely scenario. So we'll go with that assumption. Alright, so we still have a few things that are preventing us from compiling. Down here on line 45, it says we don't have a complete type. So this construct indicates that this is going to be array access. So we'll change this to an array. We are extracting 4 bits, or we're shifting right 4 bits from params and then masking. There's nothing wrong with how that's being done. So that gets us past that. Then we have a error because we have a different signature for the function than exists in the context. What we found is occasionally these function pointers return, declare that they return a signed 32-bit value, but I don't think there's any case where they actually do return a signed 32-bit value, but that changes how the compiler will treat registers and the stack. So we have a choice. We can set our signature to assign 32 and make that assumption, or we can update the context to return void. The default for these functions is to return a signed value, so I'm going to go with that, and if necessary we can change it to a signed or a void return. And there are macros then in the project which allow us to turn that on or off for some other declarations that happen, and some definitions of data that were considered it one way or the other. All right, so we're compiling, and we start with 75%, which is good. Let's look at this again. We're going to rename this to 01, so we remember what weapon we're in. I'm going to go back to the wiki. And so there was an 82% match, and we could look at that one. That's far enough away that I think we can make some. So Josh was working on this about 4 weeks ago. We should be able to make some progress, hopefully. We'll see if we can get a little further. All right, so we're compiling, but things aren't right yet. We have a bunch of these player underscore symbols. Those are guide stones for us as decompilers, which tell us that these are values that are accessed through a struct. And all of the code is going to expect offsets in a struct rather than a specific memory address to those values. And the code that gets generated, even though it's at a particular address and offset, is going to rely on that struct access. So I'm going to go through and clean these up. There's this G entities at the top, which is the player. Oops. The player symbol. This is actually a macro that goes to the first element of G entities. And we want to make sure that that is what we're accessing, as opposed to using G entities as a pointer directly to an entity. Excuse me. And one more. There's going to be a few other instances like this as well. So gplayer is the same thing. We use this symbol to tell us that this is an element in the gplayer struct. But it is going to be a struct. All right, so now we're at 78%. The next thing I'm going to do is do the same thing for GAPI. And I'll see if there's any others in here like that. Nothing that I see right now. I see that we have a few go-tos. Usually the go-tos we can get rid of pretty easily. So we have one to block 12. A couple to block 12. When this happens, for block 12, we're destroying the entity and then returning right away. We can replace those go-tos with just a call to destroy and then a return. And the compiler is going to optimize those out to be the same thing. This particular one is at the end of a huge conditional. So what I like to do is invert that condition. And then move that logic up here and return. And most of the time this matches what was in the PSP as well. it reduces the amount of the indentation level. I don't subscribe to the Torvalds philosophy of having more than 3 indent levels means your code is written poorly, but I would prefer less nested conditions if possible. So we still have this block 14. So in this case, if we fail this condition, this step 0 condition, we would otherwise do this code down here, followed by block 14. At the end of this condition, we're saying go to block 14. So we can prevent executing this without a goto by making this the else branch of that statement above, and now this will fall through right to block 14, and we don't need the goto anymore. And so that gets us to, so we've reordered some of the logic. It got us to about 80%. So I'm looking over here for how close we're getting. I haven't started looking at the assembly yet. How close is our assembly to the target assembly? I'll do that as some of the cleanup finishes up. The next thing I like to do typically is go through and start getting rid of some of the temporary variables, or renaming the variables which are used consistently throughout a lot of the functions. So this var s0 is a primitive, and that is typically given the name prim by convention. Unfortunately, there's other variables prefixed with var s0, so I don't want to do a global search and replace, but I will go through and replace all these. This var s0 underscore 2 is being used for the same purpose, so we can reuse that prim there, and that one we can do a global search and replace. So here we have a do while. The M2C decompiler likes to use do whiles instead of having matches specifically for loops, but often these are for loops. So here we have a variable var s3. It's going to be incremented down here, reassigned to var s3, and then var s3 is compared to 16. So we're going to rewrite that as a for loop, and be careful along the way to make sure that we're treating both var s3 and temp v1 both as variations of that same index that we're incrementing through. And we're going to fail to compile along the way, but that's okay, because we'll clean that up as we go. This is something that I have I run into mistakes with myself here quite a bit, where I will not follow this chain of variables necessarily, this temp v1 var s3. Those values are being stored in separate registers temporarily, just based on the way the compiler optimized them. But for our purposes as people writing code and following conventions for C-style languages, they're the same variable. And when we're finished deleting that, everything should compile again, except I don't have my I yet. And that gets us quite a bit closer as well. There is a trick down here that, being in this code enough, this Z priority will come before the draw mode. That will clean stuff up and get us a little closer. That's nicer to do when some of these other things aren't in here yet. To go from a relatively clean match to a perfect match, but I know that's going to come up, so I'm going to do it early. And I can get rid of this var3. That variable is no longer needed. And it's likely not used elsewhere. Oh, maybe it is. It's used down here as well. Oh, it's an _2 version, but it's going to be the same thing. So we'll change this one to a for loop as well. And again, we need to take care to make sure that anything that touches var3 is treated appropriately. And it looks like down here it is only used for incrementing, and it's not used with within any of the logic itself. So we can just get rid of all this. And we may be a little closer after cleaning this up as well. Or a little further. In this case, a little further. That's okay. It'll work out. We have a somewhat odd structure up here where the primitive's red value is being used in a switch. And we'll get to that eventually. Okay, so I'm going to go back up and get rid of some of these. I like to try to keep these as clean as possible and get rid of things as I go. We have another case here on line 48. We're allocating a primitive, and then we're assigning that primitive value to an index in the entity. But otherwise, this temp v0 doesn't get used. Here, the register is being used for something else, but it's as the index to the primitive is not being used again. So we can just use the field here. And get rid of that temp v0. Here we have a hand flag being added to a global that we don't know yet, or haven't seen yet. I may name that because it looks like we will need that value. We'll go back over here and look at where that's being set. I'm trying to determine whether or not this assignment is happening up here, or if this is being pulled out in a separate way. It's possible that this is in line and then optimized out, but it's also possible that setting these values on this pointer break aliasing rules that would prevent GCC from optimizing that out, and I think they do. So we're gonna leave that out for now, and I'll give it a name. So we're pulling that handed offset along with a value from memory to set all of these. There is this ordering seems a little odd to me, and it looks like the compiled version shows that as well. So we have we're setting U0, V0, U1, V1, U2, V2, etc. But in between U3 and V3, the decompiler generated this line to set R0, which doesn't follow the pattern. So we're going to move that down, and that should be a slightly closer match. The other thing is that these two up here are also likely out of order. I'm going to pull them down as well. And that may not be the right order. Let's see. These we can look at other functions which will, this order is pretty well defined in most of the weapon functions. I'm going to do that. So let's look at So I'm going to look for places that the color lookup table is being set. I'm going to look for 3 lines after and 3 lines before. And so typically it's the texture page, color lookup table, priority, and then draw mode. And most of the time that order is followed. So I'm going to emulate that order, and we'll see if those fall in. They don't right now, but it could be another issue along the way. So we'll leave it for now and see. If something else causes those to align. So I'm going through scanning on the current versus the target, looking at line numbers along the way to see if there's anything obvious that might be causing issues. And I see that setting the weapon properties and flags may be out of order. That one did not. There is this 1A. So we're loading the immediate value 1A. And the immediate value 80. The 1A is coming here, this var A1. Let's see what that's being used for. I worry that I may have gotten rid of something else that's using it. No. So this var A1 is an X offset. So we'll give it that name so we know what it is when we come back to it. Typically, updating the step is the last line here. I'm going to assume that's the case here as well, and move this up and see if I can get this in the correct order. It's actually not obvious to me why or where this is coming from in the original. I don't see the value A1 being pulled in. It is, but it's way much earlier. So around line 50. Let's move this up. That's much too early. Still too early. Okay, we'll have to figure out how or why GCC is pulling this up so high. I don't think it's happening within the for loop. It would seem odd to me, but stranger things have happened. We'll leave it down here for now. We know it needs to be set eventually, but it's not clear where or how. So on line 50 there is a oh, this is our these values are being loaded out of order, the color lookup table and tpage. It's possible that those are pulled into variables as well, and the PSP version actually might help us determine if that's the case. We can take them out and set them up here and determine if that helps us at all. So the color lookup table is going to be 100 and tpage is 19. That is somewhat helpful. But definitely not perfect. Our offset of 1A I'm trying to find this match. So we're again, I think we'll come back. So this add 1. This is the add from our for loop being optimized into the middle of this. The Z priority appears to be pulled out earlier. We'll come back. Sometimes these work out, sometimes they require a little more finesse, but I don't want to spend too much time staring at these. So here we have another instance where the decompiler does something that we don't necessarily, we need to tweak a little bit. This ext field of an entity is a union with different structs depending on the type of entity that we're looking at. In this case, we're looking at a weapon. The decompiler chose a timer as the field of the union to look at. So we're going to replace all those. And those are going to be ext weapon lifetime. Just a nicer way to read. The types are the same in this case, and the offsets are the same. It's just easier to read. And so we're storing a temporary variable with the lifetime -1, and then setting that temporary variable back to the lifetime. So that's the same as decrementing it. The PSP version has shown that this actually likely is happening in line. This shift turns out to be unnecessary, and so we're going to rewrite this actually as a pre-decrement and then comparison with 0. And that cleans up things quite a bit and gets us a few more percentages a little bit closer. So if the lifetime of the weapon is 0, we're going to play a sound effect and destroy it. We haven't seen yet where the lifetime is set, but that's likely down below. And let's make sure that we are looking at down here. So we have this X offset that's being set down here as well on line 84. It's our line 87. The debug symbols, let me make sure that the full debug symbols are on. The compiler has combined a bunch of these lines and given us the wrong offset. This is another case where this 1A is not being set where expected. It is happening at the end of this. And we can move that down. And so now our offset is showing up down here in line where it should be. Still being given the wrong. An interesting thing about MIPS assembly, or MIPS, how MIPS processors process instructions, and the reason that these are combined and treated as if they're the same line. When a branch occurs, so this particular branch, we're decrementing lifetime and then checking if it's equal to 0, and that's the branch itself. Do I go to the next line, or do I go to the line where this condition fails? These instructions implicitly capture the following instruction as well, and the following instruction will always be executed regardless of whether the branch succeeds or fails. Why is MIPS written this way, and why does that happen? I am not quite sure, but that is what happens. And that actually might be a hint for this X offset as well. So this one, let's highlight 1A again. So on our line 70, we're executing this here. My guess is that there's another branch earlier, and this is getting executed at the end of that branch. Our branch is on line 49. Let's assume that it's happening after 49. We should be missing an instruction somewhere up here for setting that 1A value. I'm not seeing it immediately, though. Let's try moving that out. Yeah, that helps quite a bit. And we can go down and see. So this would be combined with this line 49. So we can look at everything that line 49 is doing, but I don't see this particular. Okay, we'll keep going and figure out if that's the right place for that. All right, so let's clean up some more variables. And we'll check along the way to see if our ordering is correct. We're grabbing the position and subtracting 6 from the current player position. And so this will be our y offset. So anytime we see var s4, we'll change it to a y offset. These are out of order, and they may be flipped. What I've seen on the PSP version is while this appears to be loaded twice, I'm going to switch them for now. This second calculation actually isn't reloading this variable. It's just subtracting the difference between the two. And if we look at our generated assembly, we're still doing the right thing. So even though these lines are out of order, we're loading y after x. The compiler has generated that we're loading x before, or sorry, loading y before x. Temp S5 we'll use as our x offset. We already have an x offset. Let me make sure that that is not being used down here. It is, so I can't reuse that variable. We may be able to call these x and y. In our switch, we're using temp v1_2. And otherwise that is not being used, so we'll just switch directly on the R1 field. And get rid of that. And then in our first case, we're doing something similar above, as to the timer above, subtracting 1 from our 0 and then reassigning that value and using that value elsewhere. In all of these cases, we can just do the decrement here. It may also be inline, but then we're just checking that R0 against the value 0. And this may be an equality check, but it may just be a negation of the value, and it looks like negation of the value is what the compiler wanted. And let me make sure that we're matching down here. In this case as well, we will need to put this in line. We don't want to reload this variable after we've decremented it, and sometimes GCC will do that. We want to make sure that it knows that it can use a cached value between when the value is decremented and when it's being evaluated in this condition. The way our code is written, it can't change. All right, so continuing on. var v0 is going to be This is where we're going to run into some problems related to variables. So this is the x on one side of our primitive. Our primitives are quads, so we're going to be setting up the 4 corners of a primitive. So we can continue to call this var0, but it's going to be basically the left side of our primitive. So maybe I'll call it that, and then we can rename as appropriate. But it's nice to have human readable names in the meantime. And then likewise, this is going to be the right side, this var v1. And depending on what direction you're facing, these differ. So close, far might be better names, but we'll go with what we have for now. And then this temp v1 is going to be this is going to be our the high side of our y. And actually, we can probably just get rid of that altogether. And then the other is going to be our low side. So this is setting up our the box that the texture will be drawn to. This draw mode is being set to the inverse of draw flag 3. Let's look at what that is. Sorry, draw flag 4, so draw colors. And I like watching these to make sure that I'm not putting the wrong value. So we're going to invert that, and that looks right. So I said 3, I meant the 3rd bit. And then we can increment that. So looking at the, so we have several registers that are mismatched, and that's fine. As other parts of the code get closer, those will begin to match more. One concern that I have is things like this draw mode. This is likely happening after, and that'll probably help here. Oh, actually, here's my constant, and I did get it wrong. Oh, go back to make sure I have the window up. I did get my constant wrong, and it is going to be an unknown flag. And that, no, it's not the unknown flag. 7, what is a 7? How about hide? There we go. It's been a rough weekend. But we're still not completely aligned. On 123, this increment is out of order. I wouldn't necessarily expect those to be separated from the x and the y, setting the x and the y. So we'll have to figure out what is going on there too. The other weapon 001 function that I was working on was entity weapon attack, and it had a lot of the same issues where things that seem pretty standard in most weapons and flow logically and seem like any modern code might, they weren't working as expected, and maybe this one's the same. We'll see. We'll call this Y. And then we'll go on to the next case and see if those shake out at all. We get the same thing here on line 130, where the way that the decompiler ordered these seems mismatched from what we might otherwise do. And so whether or not then these are before or after, one thing I realized along the way is we were at about 85% match, and we've gone down quite a bit since then. I'm not too concerned yet. It may be that registers are causing that. There definitely is ordering issues that will have to be worked out. But we'll figure it out. This is going to be very similar construct as above. So we're going to be decrementing the red value and then comparing that to 0. Pointer. And so we can see some of the offsets here and the order that they've been chosen by the compiler. So it's loading offset 10 and then offset C of the primitive. And we can go look at what those are. So offset C is U0, but the way that the compiler is generating this, it has loaded offset 10 first, which is R1. So let's move R1 up. That doesn't necessarily mean that that's the order that the code needs to be in, because the compiler is going to choose an order that it believes is most optimal. And that's not necessarily the order that that we write the code. Compiler writers, there's a funny article from a couple days ago that was on Hacker News about how it was actually DJB, who's Daniel J. Bernstein, who writes a lot of security-related, cryptography-related things. He's a professor who spends a lot of his, and researcher, spends a lot of his time writing about software security. And he has significant beef with compiler writers who write things for odd edge cases that they think should be faster. Hello, Crudifar. Thanks for joining the stream. Thanks for chatting. So again, we're going to go through and try to figure out what order that these were originally in. So offset 10 was this R1, which is out of order. Offset 4 is R0, and then the next one in our compiler is this offset 18, which is U1, and we can try moving that out of order as well, but I doubt that those were out of order. So something else is going on there, and it could be that these are being pulled out and then mutated and then being reassigned, or something else. We're going to keep going for now because that's not super pressing. And again, there's other things that may happen later on where the change convinces the compiler to reorder all of these things. So down in this last one, we're rewriting this decrement, and we'll reorder these into the numerical order, and those work out except for this draw mode. Actually, U3 is the one that it has decided to reorder strangely. And then there's several instructions below that that we're not getting. So let's pull that up. So that packs them the right way, but it is not doing the right thing. We'll leave it like this. Oh, why did this? Sometimes when you're editing decomp.me, it waits for pauses and keystrokes to send things back to the compiler, and sometimes the changes don't register between those pauses. This is going to be unnecessary, and we can get rid of this temp-v06. Alright, so we're at 85%. We're about an hour in, and I'm not sure. Sometimes these end up falling into place right near the end. I'm not sure about this one, but we'll keep going and see what we can find. Let's get rid of some of these other variables. VO2 we already got rid of. VO4 is already gone. And we may take this opportunity actually to go look at the PSP version. This is one that I didn't necessarily like the name of. So we need a... I don't think we have an X variable yet. We do... And it was being used up here, but is it being used elsewhere? It is. So I can't reuse that. Oh, but it looks like I can reuse X offset. So I'm going to rename this and then we have X to reuse. That did hurt the match. Oh no. I screwed something up. So this, I have these at the end of both of these branches. I'm guessing that this was pulled out and may even be closer to this. I was having trouble finding where this assignment was being done in the original and it looks like it's being done down here closer to this assignment, which makes a lot of sense. All right, so we still have some issues above. It's certainly possible that these globals are being pulled in elsewhere since they're all the same, and then being reused. I'm not quite sure about that. There's a few other variables we can go through and rename as well, and see if so this comparison is where we are in the player animation. So let's call this animation frame. This one is gone. So if you've joined recently, we are decompiling one of the functions for the hand attacks in Castlevania Symphony of the Night. We now have names for all of our variables, which is helpful. Some of these may still be able to go away. So going from top to bottom again, there's still some assignments that are happening out of order. And curiously, there's some of these loads are happening out of order as well. So there is something in there, and we could look at that might be the next step, is to go look at the PSP version and do a comparison there and see if it gives us any more information. Comparatively, many of the other weapon functions were a bit more straightforward. So let's do that. Let's take a look at the PSP version and see if we can get any hints. So I'll create a new scratch. In the background, I'm going to go find that version. And the PSP version is also a MIPS assembly but it's compiled with the MetroWorks compiler instead of GCC, and it's compiled with optimizations off. Which produces a larger, much more code, but also code that frequently is more straightforward and almost universally in order. So I'm going to create a scratch with the PlayStation Portable, and there are definitely symbols in here that I'm not going to have, but we're not going to worry about the decompiled version. We'll just worry about how our code matches up. So I'm going to take this PS1 version, and we'll paste it in there, and we should be compiling. And so this looks much worse. Oh, 66%, versus the PlayStation version was at 85%. What can we do? That's not too concerning. There are significant enough differences between the two that when there are things that are out of order or incorrect, the errors tend to grow much more quickly on the PSP side. But we can look at some of these, especially around line 46, and see if we can get any idea from there what might be going on. In almost all cases, the immediate values are going to be wrong or different, and so that's not a concern. There are some mnemonics in the PSP version that I'm not familiar with yet. But the PSP version in general does seem to make it easier to find what the correct ordering of things is. So in our code, we're loading a byte from here, and the PSP version is loading the address. And so it's possible that this was an array the whole time. And when that happens, we need to load the address and then load an offset to that address. And it's also possible that this was being dereferenced. That's odd. At least in the PlayStation 1 version loads and adds like this. It's loading the high. An instruction in MIPS is 32 bits, but so is an address. So we can't load an entire address in a single instruction. So we have to split it up into high bits and low bits. And typically that is how those addresses are loaded. It's possible that this is a pointer as well. I don't think we looked at what this one was. Not exactly correct. Oh, and that could be that these, I'm looking at the wrong lines. We'll see if that's the case. So let's reorder these. Not quite. This one's so there's other things around here where these may also be out of order. That doesn't get us closer. I'm going to skip past that because I'm not finding success there. So let's go down and find our where we are after this. So in our code, we're storing this I value in R0. However, and we got that from the decompiled PlayStation version. R0 was the value at offset 4 in the entity. The PSP version says we're storing this in offset 4. And offset 4 is the Y position. I'm sorry, we're storing in offset 4 of the primitive. I'm looking at the entity. That isn't in the game today. It's saying that we're storing this in. We're storing in offset 4. It's saying store this in offset 8, which is the X position. That makes a lot more sense. We can try moving that back to the PlayStation version and see if the PlayStation version likes that anymore. It doesn't. And it could be that these are actually differences between the PlayStation and the PSP version. We'll see as we get closer. There are a few cases here where we're masking, where the mask isn't necessarily happening, and that could be because we have a an incorrect type along the way, but that didn't seem to be the case either. If this is the first time joining the stream, usually we have success and get something decompiled, and that's okay, because it's not always, this is what makes decompilation difficult and why it's not done every day. So in this case, it looks like this ordering is correct from the PlayStation version. We're setting the flags and then setting the properties. We have an immediate difference, and that's because this function hasn't been named yet. The offset hasn't been defined as a symbol for the PlayStation version. I'm not concerned about that. Then continuing on, the next area that we see a difference is in this destroy entity. This could be because this condition is inverted. And let's go back up to where this is happening on line 40. On line 40 here we have a function call in our target that we don't have in the original. So we're going to negate this case, and that will allow these to align. What's neat about doing this with the PSP version, it helps us with ordering quite a bit. But taking this back to GCC, this will compile to effectively the same thing, and likely is more correct in terms of how the original code was written. So we'll go back down here. In many of these cases, we have to do this where we can pull code up and reorder it. And logically, it's equivalent. And as long as it's equivalent logically, then we should compile to the same binary. All right, so let's go down. Down here on line 78, the same thing here. An immediate value is this call to the Play Sound Effects API. There's nothing mapped there, so we don't have the advantage of having the correct or some guidepost symbol there for us. On line 87, there is work here pulling primitive information out. There's a add and shift in the index that is missing. Or no, I'm sorry, there's an add and shift in the index that we have, but is missing from the original. I'm going to, when I was decompiling the PlayStation version, I removed the index but it appears that the PSP version would like that index in place. Or possibly not. Well, this is not working out as well as I had hoped. Let's go down to the bottom, and we'll figure out the ordering down here. And we should be able to do that. Okay, so we have the item at offset C being loaded and manipulated, whereas the original, so same instructions, just different offsets. It looks like these U2 and U3 may be happening first. And they may be happening backwards. Let's go from the top. So here we're loading offset 10, which is R1. And then subtracting 30 from it. Okay, that matches. So this is not what the decompiler gave us, but we can go through now and use these offsets. So we're loading bytes at different offsets in this primitive object, and then doing these various operations on them. Definitely curious how off the decompiler was. Usually the decompiler is pretty reasonable. And it could be that this is a difference between the PSP version and the PlayStation version as well. So it might not be as egregious as the decompiler doing something. It may just be that there are differences between the versions. So here we're doing the same thing. So we're looking at the primitive reds and kind of fading them out. And offset 34. Offset 34 is actually the next entry in this array. Primitives are only, the last field in a primitive is offset 32 that we have defined. That is odd. So I actually don't know what. It'll take more research to figure out what's going to go there. So the next one is we're going to load the immediate value 2, and then we're going to store that in offset 8. And offset 8 of the primitive is x0. So yeah, we are missing something. I'm going to put a placeholder here. We'll cast this primitive as a an unsigned 8 pointer. And we'll set the value and just mark this as fake. Because this, either it is an alternate primitive, which it could be. There are alternate primitives that are available. None of them I see, though, are larger than hex 34 in size, though, which this would need to be. So let's find this line 39 and see what was generated here. That's interesting as well. So this offset is significantly higher than I was expecting. Always fun. So this gave us an offset of 6C. Okay. Oh, let's try this. We'll do this as a placeholder to get the size right. Yeah, so I'm not sure what this pointer is. I will leave it like this though, because it's an obvious mismatch, and then we can keep going on. So then we have a bunch of stores and loads here, but we continue on, and it's continuing to go on past the end of this primitive structure, at least the one I'm familiar with. So it is definitely possible that the primitives on PSP, or at least for weapons, are a different size. In which case, this is not much of a help. We are getting reasonably close, though. There's one store of 0 in offset 14, which is X1. But in it's attempting to store a byte at offset 16, and we are not operating on a byte. So it's possible that I am just using the wrong field altogether, or the wrong structure altogether. However, the rest of how this is written looks very much like the other primitive code. Yeah, this is similar, where it is looking to store a byte. Well, so interestingly, this did not help as much as I was hoping. I'm not sure if these early weapons, I haven't looked at weapon 1, or weapon 0, we can look at that before we end the stream. This is many of the cutting weapons, the normal swords. The way that this function is written is very similar to the other weapon functions. So it's fists being so different is interesting. I will open this up, and we can look at some of the animations for the different fist weapons, if knuckle duster, jewel knuckle, etc. If those have any, if the animations for those are different. I'm not familiar with the animations for each of those. And so it's possible that there are unique animations. Just looking at the animation, the jewel knuckle is potentially lighter. Let's look at Tulkus. Okay, so the hues do change depending on which weapon is being used. It's often good to go back and look at the weapon animations to see where what some of the logic in the code is doing. So there is things around bounding boxes and other things like that that may get pulled out in the weapon functions, whether they're colliding with something or not. In this case, it looks primarily to be related to setting up the color of the trail. So today wasn't a success. Last Thursday, if you tuned into the stream, we were working on several of the Weapon 15 functions, and those were submitted on Saturday morning. I ended up finishing the last one on Friday with the help of Biz Murphy. So we watched, we were able to get through 2 of them successfully, and then the third had a little bit of a challenge, again related to ordering. The PSP version was helpful in figuring that one out. These were Masamune and Muramasa, weapons like that. More straightforward and more similar to many of the other weapons that I've done. There's more work to be done here on these punching weapons, and that's probably what I'll spend my afternoon doing is looking into these and figuring out where some of these are going sideways. If there's anything, we can pull in our PSP code back to the PlayStation and see if any of that's helping or hurting. It brought us a ways back, so there may be differences here that need to be reconciled, and that's okay. We'll figure it out. So I'll be back on tomorrow around 11 a.m. Mountain Standard Time. If you want to know more about decompiling Castlevania Symphony of the Night, you can go to soten.z.dev and follow the progress there. There's links to the GitHub repository and the Discord server. A lot of discussion in the Discord server about decompiling, about various things people have found related to everything. Sprites, audio. There's a lot of work being done throughout the game. We're still at, we didn't get to knock down any weapons today. We're still at 15 weapons remaining in the weapon 0 binary. Hopefully some of that gets cleaned up later tonight and we can make a little progress before tomorrow's stream. If there's anything that people want to see specifically, I would like to get into a debugger and go through. I still believe there's, I did this off stream a couple weeks ago, but going through the Richter prologue, there's several functions related to entities in that prologue that we can set breakpoints for and determine what their meanings are and set those names in the code, and then have more information for other people to go through and name things, and it makes sharing that code then across stages easier. I know that there's several vessels and then the animations for when those vessels break that we can probably figure out the names for. By figuring out the names, we can name them things that will make sense to other people, and when those items are seen like in Castle Wall and other places like that, likely that code can be reused. So I think that's it for today. Thanks everybody for watching, and we'll see if we can get more success tomorrow. Thanks for watching.